Hello, good morning, students of 3P7, and also whoever is watching my class, my lesson today. Good morning to everyone. Okay, so first of all, can you please give me a feedback on whether I'm loud and clear, whether you're able to hear me? Good morning. Okay, at the meantime, I will share screen. Okay, hello, Shu Hui. Good morning, Jia Tong. All right. Okay. I think you can hear me. Yeah. Can you hear me? Please do give me feedback. Is my voice clear or not? Okay. I can see my 3P7. Right. Jia Tong. Okay. Corsin, Crystal. Okay. Crystal can hear. All right. Thank you very much for your feedback. Okay. Now today I will go through transformer. Okay. I think last lesson we have done a little bit on transformer, but because of the recording purposes, so I'll go through the transformer again. Okay, and also the differences and the similarities between the types of transformer. Okay, so after this class, we'll go to Google Meet, all right, to do some questions. All right, so we will just do the lessons sharing here. Okay, let me go through the lesson. Let's start with transformer. So transformer is actually a device, all right, it's a device that is used quite a lot nowadays. Okay, what is the function? First of all, you need to know the function. Okay, when you see from the word transform means is to change. So a transformer changes something. Transformer specifically is a device which changes the, all right, now the keyword here is, the next word is important. You cannot say anything else except the word is voltage. It changes the voltage of a current. And the current that they can change is only alternating current. So it changes the voltage of the alternating current, okay, AC, not DC, right? AC, you have learned it earlier, you have two types of current, AC and DC. So this one changes, the transformer changes, it works on AC only. It doesn't work on AC or DC. It works on AC. It changes the voltage of the AC current, right? Alternating current, either two ways, whether you take it from a lesser voltage, change it to a higher voltage, okay, means from less to more, that means it's increasing. You can either increase the voltage, or the other way around, if you have a higher voltage and you want to change it to a lower voltage, that we call a reducing. So either you increase or it reduces, or it decreases the voltage. So here you can see actually there are two types of transformer. Okay, so we got to see the types and how what's the function. Okay, now first of all, why do we need a transformer? What is the function of a transformer? Okay, Stella, correct, as change. Yeah, so the transform is to change. So why do we need a transformer? We in fact use a lot of transformer in our house, our home electrical device. So first of all, most of you, I think everyone will have a laptop at home now, all right? So you have a laptop here and you need to charge it. Okay, you need to charge it because it cannot work on battery all the time. It has an internal battery, but that one is only for temporary storage. Just like any battery, it is to store the charges. But as you run the computer, it uses up the charges, so the supply will become lesser. Okay, so you have to recharge your computer or your laptop. So what you need to do is you have to plug it into the charging wire, and you'll notice you have one device here, which is quite a big piece of a device. Okay, it's quite heavy, right? Looks as sometimes it's as big as the handphone, right? This size. So it's quite heavy. Now, why do you need that? Why can't you just have that whole thing with the wire from the socket, right? From the socket, from the power point here, goes direct into your laptop. And also for your handphone, you have this piece of item here, all right? Usually at the plug here, right? Why is it so big? What's inside there? Okay. And in the ceiling fan regulator, where you control the speed of the fan, there is also an item inside here called the transformer. Okay, why do you need to use transformer? Okay, all these items have transformers. Okay. First of all, if you look at our battery, the supply for our laptop, so the voltage for our laptop is around 9 to 11 volts. Okay, so imagine this is your laptop, right? This is your laptop, and you will need to charge it. So you need to charge it, you must have your power supply. Your power supply is of course the supply you take from the from this socket, isn't it? For you plug into the wall socket with your socket switch there. Now this one uses AC current. The electricity that comes to our houses is alternating current. It is supplied by Tenaga Nasional Berhad, so TNB, right? This is our national energy supplier to all the homes, right? So, but this is Tenaga Nasional Berhad. When they generate the electricity, the voltage of the electricity is actually quite high, a few thousand, hundreds of kilovolts, okay, very high. Then when it comes to our houses, it will be changed to 240. Okay, so this one we later we learn another next week we learn about the different voltage of the electrical supply that comes to our houses. So when it comes into our houses, it's already 240 volts. Okay, 240 volts. It's the alternating current. Okay, it's 240 volts. Okay, right now this, if you plug it into your laptop, all right, this 240 is a bit too high, actually quite high, because our laptop requires about 9 to 11 volts only. So it's not compatible. Your 240 volt is going to damage your laptop. So you need something to change the voltage. You need to let it pass through a what we call adapter. We always call that thing adapter. And inside the adapter, there is a transformer. So this adapter here functions to convert your 240 volt into something that is less, which is about 9 to 11 volts, which can be used by your laptop. Okay, by your laptop. So here inside your adapter, why we need that big piece of thing there? That's because inside here you have a transformer to transform the what? Not current, the voltage. Okay, remember use the correct word. It's called voltage. So to transform it. So same principle also for your handphone. Your handphone probably uses about 5 volts. Okay, the current 5 volts. But again, if you plug it directly into your power point in the socket in the wall there, it gives you 240 volts. This is the how strong the voltage that is supplied to our houses. Okay, in Malaysia, we use 240. Other countries like Japan, when the electrical the current that comes into the houses is not 240. They use 110 volts. So different countries will have set their own different amounts of current, the voltage that is applied to the houses. So we use 240, very similar to in Britain or in UK, which is about 230 or 240, around there. Okay, USA will be different. Right, other countries will be different. So different countries, they will set their voltage, right, that is supplied to the houses differently. So here we also have that piece of thing there that you at the socket there, which is also has a transformer to convert the voltage from 240 to 5 volts so that your handphone can use it. Okay, otherwise it will damage your handphone. Okay, because the voltage is incompatible. That means 不适合, it's not suitable. Okay, so now we've seen the function of change the voltage, not current, all right, not anything else. So changing the voltage of what type of current? You also have to mention AC, changing the voltage of an alternating current. Okay, so that is the function. Okay, next one. What is inside a transformer? What are the parts? So in a transformer, there are actually 3 important parts only. Okay, so you need to remember the names of the 3 parts. Later you will see the types of transformer. So every transformer will have basically 3 parts. Okay, basically you have these 3 parts only. So let me check whether my mic is okay. My mic seems to be okay. So these 3 parts here, number 1 is a laminated soft iron core. So this middle part, core is like in Cantonese we say the sum. Sum is like the middle part. Okay, the basic, we call the middle, the most, the central thing is called a core. Okay, it's called we call it sum in Mandarin or in Cantonese. Okay, so this iron core is made of iron. So it's made of iron metal, and it is you can notice that it is quite thin, right? A few pieces like that is laminated. Laminated means joined together. All right, so pieces of metal, okay, and then you are joining it together, you get a core, which is like a square shape. And then around the sides, you have wire coiling around it. So you actually one long wire. You have to coil around the wing, one side of the iron core. So remember the words, this is core, this is coil. Do not mix up. Okay, core means the middle part, core. The coil is talking about wire which you wind it around and around and around. That is called a coil. So on one side, you call it a primary coil. Okay, and on the other side of the wing here, you call it a secondary coil. So there are three things. One is the iron core, say it properly. Number two is the primary coil. Number three is the secondary coil. So these are the three things that you have in every transformer. Okay, now here look at primary coil. Primary coil is always connected to the AC supply. This means this is the current that you want to change the voltage. This is what we call the input. Input is what you put inside. This is called the input voltage, not current, input voltage. So let's say I want to change my 240 volt lah. And just like that one, now I'm charging my, let's say, laptop or handphone, right? Now the input voltage is the current which has 240 volts. So this is the one you want to change. It's called the input voltage. It's always connected to the primary coil. So you look at the connection. When this is input, it's always with the primary coil, that side. Okay, never on the other side. So input is always at the primary coil. Now then the other side, all right, so you're going to have this magnetic flux and all that, all these things. So this voltage will be changed and it comes out this side. So this is the voltage that is going to be produced. We call it the output. Output is your hasil, what you get from it. This is called the output. Okay, the output voltage will not be the same as your 240 because we're changing it. Okay, and it's connected to the load lah. The load is probably something that you want that uses this voltage lah. For example, it can be a bulb, it can be a laptop lah, it can be a handphone. The thing that uses the output voltage, the device that uses the output voltage. For example, a bulb, that is called the load lah. Okay, and always take note that at the here secondary coil is always with the output. Okay, so if you're not sure which is secondary, which is primary, you look at whether they label input or output. If they label that side output, that means that side is secondary coil. If this side they label as input voltage, that means that is your primary coil. Okay, so you need to see how it's connected. All right, now, so we have seen the three parts, right? Iron core, primary coil, secondary coil. Okay, next thing we need to see is there are how many types of transformers. Okay, just now we noticed we said the function of transformer is either to increase or decrease the voltage. So actually here means there are two types. Your transformer can either increase the voltage or your transformer can also reduce the voltage. So in that case, there are two types of transformers. So two types of transformer will be step up transformer and another one is step down transformer. Now take note now how you write your word step up. I see many students write set up, set up transformer or set down transformer. Wrong. So be careful. It's not set, but it is step up. Step up means is to increase it. Step up. So what how do you see or what's the difference between a step up and a step down transformer, okay, in terms of structure? Okay, so this is a repeat of what I just told you, right? Transformer, three components, right? 1, 2, 3. And the two types are step up and step down. Now, how do you know which is step up and step down? Okay, first of all, let's look at this diagram. PC stands for primary coil. And this is your input voltage. Okay, input is I want to change this. Just like I want to change the current of the current that is coming to charge my laptop or my handphone. I cannot put 240. So I need to convert to something lower. So I primary coil. And then you see when the current passes through this one, right, the voltage will be changed. The voltage will be, let's say, changed to 9 volts. Earlier on it's 240. So you can see that from 240 to become 9 volts, your input is 240, your output becomes 9. So is it an increase or decrease of the voltage? Okay, maybe you can type in, every one of you type in your word there. Is it an increase or decrease of the voltage? This transformer, does it increase or does it decrease the voltage? Okay, so this is PC, primary coil. The other side will be secondary coil. Okay, I'm waiting for your reply. Maybe you can just type in your chat there. Is it increasing or decreasing the voltage now? This particular transformer. Okay, I see some response. Let me just highlight this one first. Okay, this is PC. This is secondary coil. Yes, I see decrease. Many people say decrease, 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 decrease. Correct, correct. All of you are correct. So decrease is because you have more. 240 is definitely more. 9 is less. So more to less, that means you are reducing the voltage. I keep on saying current. Okay, reducing the voltage. When you're reducing the voltage, what is the type of transformer? What type of transformer it is? If you're reducing the voltage. Okay, just now we mentioned there are two types. So the names here are whether it's step up or step down. So now it's from higher to lower. So what do you think? Is it a step up or a step down transformer? Okay, step up or step down. So what kind of transformer this is? Something transformer. Something from 240 to 9. Yes, step down, correct. Step down. So step down means you are decreasing the voltage. This is step down. Okay, and you observe, I want you to observe something else. You look at the coil. If this is a step down transformer, it's like this. When you have a step down transformer, that means more on there'll be more coils on the input, on the primary coil, and there'll be less coil at the secondary coil. A step down transformer will always have the primary coil more, the turns, okay, the bilangan, how many times you wind around the core. So the primary coil will have more coils. Let's say here is 500. And then for the secondary coil, it will be less than 500, maybe 200. You can see I purposely draw there. The coils are different, the number. Okay, so here I put more. On this side, I put a black color. Okay, on this side, I put more coils, right? And this side is less coils to show that actually when you have less coil, your current that comes out, the voltage that comes out is actually lower. Okay, now this is a step down. What happens if we look at another example? Oh, let's look at the symbol first. If a symbol, all right, symbol for easy to draw the symbol of transformer. Usually we draw two lines here to signify the iron core. Okay, two lines here to signify iron core. I think you learned this in RBT maybe. Okay, so for primary coil, because it's a step down transformer, it's got more on this side. So when you draw it, you are going to put like this, more coils. Okay, this would show this is your AC, this is your input current, input voltage. And then for the secondary voltage, secondary coil, you find that this is less. So when you draw it, you have to draw less. This is the symbol of, when you look at this symbol, right? Let's say this is the AC, all right? This is the input voltage. And this is the output voltage. From here, you will know whether it's a step up or step down. Okay. So how do you see? Okay, look at the number. If this is input voltage, that means this is a PC, primary coil. If that side is the output voltage, it will be the secondary coil. Okay, and then the primary coil will have more coils than secondary coil. If this happens, this is a step down. Okay, becomes more, becomes less. From more coils on this side, then you have less coil. This is a step down transformer. All right, okay, so Stella, you write that the number of primary coil is more than the number of secondary coil. This is for, this is for the step down. Okay, this is one of the indications, one of the characteristics of a step down transformer. You would see the number of coils. Primary coil more than secondary coil. Okay, next one. What about the other one? Step up. Okay, how does the step up look like? Step up, you have the iron core as well. Now here, you will see example of a step up transformer. You can see here, I put 10 volts. This is the input. I want to change this from 10 volts to 200 volt, let's say. Okay, so I need to hook it up to a step-up transformer. This is a step-up. But in terms of the coils, the number of coils, you will see properly, for step-up transformer, here at the primary coil, you will have less. Okay, but on the secondary coil, I need to draw more. This one more. The wires here, actually the coiling is more. So here PC, primary coil, what? Less than secondary coil. This will be a step up transformer. Or you can put the other way around. So a secondary coil, you can also say this way, secondary coil is more than primary coil. Yeah, okay, step up transformer, for step up transformer, the number of primary coil is less than the number of the secondary coil. Okay, so secondary coil will be more. So this is how you see, right? So you look here, the coiling here compared to here. And you must know which is input, which is output. Okay, so now we are going into actually the differences of the two types of transformer. So actually I've gone into here, right? So how do you, when the question asks you for the differences between step up and step down transformer, what can you talk about? There are two things you can talk about. Okay, two things. If you look at the structure, the difference here, okay, the two things. Number one here is you talk about the coil. Just now we just mentioned, talk about the coil, the number of coil. Okay, just now we said here, this is number one. So for step up transformer, the number of turns, you can also say turns or coils, of primary coil is less than the secondary coil. So your PC here, right, will be less than the SC. So you can see very clearly, this side is less coil, this side is more coil, isn't it? Then this is a step up transformer. Another way you can talk about it is look at the AC, the voltage. Here they don't give you the number, right? But if you look at the voltage, another way to see is, you see the second way to compare. Second way to compare your step up and step down. Look at the voltage. If the input voltage is less than the output voltage, input is this side, right? Input, let's say this is 10 volts. Then you come out after passing through the transformer, you will get, let's say, 200 volts. Okay, let's say, so input across the primary coil will be lower. It will be lower than the secondary voltage, which is called the output. Okay, so this side less, this side more. Okay, so there are two ways to see whether or to explain the differences between step up and step down. So first talk about the number of turns, right? That's one. Compare both sides. Another one is to talk about the input and output voltage on this transformer. Okay, now let's look at step up. Step up will be the reverse. Step up will be the reverse. Okay, so it goes like this. When you look at let's look at the turns first. So if you look at the coils, here looks like more, and this one on this side is less. You see that, right? You see the difference here? So one of the characters you can write here is the number of turns in the primary coil is more than the secondary coil. That means, right, in short form, primary coil, the turns will be more than the secondary coil. Okay, I think you're familiar with the mathematics symbol, isn't it? If it points like this, means what is on the left is more than the right. If it points this way, what is on the left will be less than what is on the right. Okay, so PC is more than SC. Okay, another way to see is you look at the voltage. So here, the voltage on the input side, or we call it input voltage, will be higher than the secondary voltage or the output voltage. So here more, let's say your 240 volts. Okay, you want to charge your phone, it goes down to 5 volts. So it is step down transformer. Right, now, how do you explain the differences? If the question asks you, compare or state the differences between step up transformer and step down transformer. You know the facts, but most of the students, they do not get marks correctly. They don't get the full marks because the way they write. When you want to write something to compare A and B, All right, what's the difference between A and B? Number one, make sure you both sides also must say. You must say A is like this, but B is like that. You cannot just say A is like this, full stop. Okay, when you say A is like this, you didn't say your B is like this, you're not comparing. You're not saying the differences. So you make sure both sides also you need to mention. Okay, so how do you write this? So if I say state or describe one difference between step up transformer and step down transformer. Okay, so what you can write is look at this one. You start a sentence like this. For step up transformer, comma, you need to you're talking about which one first, because if you don't say, it's going very confusing. I don't know whether you're talking about step up or you step down, which one more, which one less. Okay, you start the sentence like this. For step up transformer, comma, the number of turns of primary coil is less than the secondary coil. Okay, not yet finished, but because you only talk about step up, you didn't talk about step down. So you have to add on by saying, but for step down transformer, the number of turns of the primary coil is more than the secondary coil. You see, the sentence is so long, right? The sentence is so long, but it is only 1 mark because you have to compare both sides. If you only say half, you cannot get 1 mark also. Even though one side is already so long, right? You already write so many words, you still cannot get the points because you didn't compare, you didn't say the other side. Okay, now this is a major problem of students. When they want to write, they just write on one side. They always forget. You cannot get your marks like that. Okay, when you compare something, both sides also you must show the difference. Okay, so that is first point. Now you can talk about it in terms of the voltage. So let's say I want to give another reason. Give another reason why. What's the difference between the step-up transformer and step-down transformer? Okay, the other reason is for step-up transformer, comma, the input voltage, all right, across the primary coil is lower than the output voltage across the secondary coil. Okay, the input voltage is lower than the secondary coil as the output voltage. Okay. But don't forget, but for step-down transformer, the input voltage across the primary coil, or if you say so, never mind, you just say input voltage is higher than output voltage. Also can. Okay, that is already complete because you mentioned this side, you mentioned that side, you put the but there in between. Okay, so this is the differences. Now, what about the similarities? What can you say if the question also asks you? If the question asks you compare and contrast. When you say compare and contrast, you have to say the similarities and the differences, not just the differences. To be on the safe side, you must mention similarity as well. Okay, this is when you come to upper form. When you talk about biology, chemistry, and physics, I want to explain all these things. To be more complete, your compare and contrast, you must have similarity. That means 相同的那个共同的properties, the same properties that both sides also got. And you talk about the differences. What is this and what is that? What's the difference? Okay, can anyone suggest, maybe you can write over there, what similarity can you talk about between your step up and step down? Okay, you just try first. Okay, what can you say? Try to look for the things that both also have. It's the easiest way. Next time I ask to tell you how to find similarities. You just look at the two diagrams or look at the two things that you're supposed to compare. Think what are the things that they both have or they both can do. Look at the function, look at the parts and the structure. What is the same? This one got, that one also got. Okay, so that will be the best indication for you to write a similarity. Okay, so any answers for similarity? Any answers for similarities? Okay, let me just check. You can see the diagram. You can look at the diagram also in the textbook. It is on page 178. Yes. We're going to talk about similarity. What are you going to talk about? Yes, any answer? It's easy. You just look at it. It's staring at you in the face. Okay, you can see it very clearly what that they both also have. So, first of all, talk about function. I start the sentence first, both. Easiest way to talk about similarity is to say both. Okay, both got what? Both can do what? So, anyone? No answer. No answer, I'm going to give you answer. Wait. Both have Primary core and secondary core. Yes, there's one. All right, but add one more. Not only these two parts. Remember, every transformer has three parts. So you're talking about primary core, secondary core. There's one more part that both also have. Stella, okay, both consist two cores or wires containing different number of turns. Okay, that means two core or wire. So be more specific. What is the core or wire called? Primary and secondary. So you're missing one more, Patricia, which is both have iron core. This one. Yes, both iron core, primary coil, and secondary coil. This is one similarity. Okay, primary, yeah, iron core, primary, and secondary. Let me check answers. Have voltage. Voltage is because of the current. Not so important such a similarity lah. So talk about the structure, what they have. Voltage, iron core, yes, iron core, missing iron core. Yes, increase and decrease the voltage, both have iron core, yes, both have the laminated soft coil. Okay, so the next point you can talk about both function to do what? Function to have the same function to increase, that one is given by Stella, right? Okay, wait, yeah, okay, increase and decrease the voltage. Both function to increase or decrease the voltage. If you don't want to say increase or decrease, you can change it with the word change. Change, or you can say increase or decrease the voltage of what? What kind of current? Of alternating current. Okay, of alternating current. So this is the similarity lah. Just put it all together, right? Iron core, primary core, secondary core is one on its own. Then another one first one you're talking about the structure. The second one is similarity in forms of function. They both function, they change the current, change the voltage, okay, of an alternating current. Okay, done, right? So this is one more thing I want to show you. This is the in the regulator of the fan, our ceiling fan. So the current that comes in from of course, it runs on the mains from the TNB, right? So this is 240 volts. This is the AC. This is the input. How you control the speed of the fan? Okay, actually, you change the voltage. All right. So it's either if you 2, 4, 6, 8, or 10 volt. So if you want the fan to be slower, then you turn to a maybe 2 volt. Then you want the fan to go faster, then you convert it to 10 volts. Okay, so something like that. So this is the input voltage here, and this side is the output. So they will have a transformer inside that regulator there. Okay, output voltage. Right, now let's talk about calculation. I'll do another day because you'll be too confused to learn too many new things. Now we go on to an experiment. Now this experiment we can't do in school because we're not in school, but this is one of the wajib experiment. So I would like you to write it down on paper. This is your 7th experiment wajib. Okay, the 7th one, which you have to write on paper and then hand it to me lah. So depends on when the school reopens. So let's say if the school doesn't reopen, let's say by, I don't know, October maybe, almost end of the year, let's say, then I'm afraid you will have to type it on the document, Google document, and send it over to me in soft copy. Okay, so at the moment, hold on first. You can write it on paper first, doesn't matter. So maybe if schools resumes in the future, maybe next few months, then you can hand up to me on paper. But by October, I will let you know if let's say we see by until end of the year also don't have whatever, right? Then you please convert your remaining experiments, the experiments that you did not manage to hand in to me before the school closed that day, right? You have to put it on, type it out. Okay, don't copy and paste the actual words. I want you to type it out yourself. Diagram you can copy and paste, right? And then you send over to me in soft copy. Okay, I will mark it from there. Okay, now let's look at this one. This one, I explained the experiment first. The only problem is you don't have the skill of setting up the wire and so on, but the values are here. Okay, not only values, this is, you look at brightness only. Okay, we discuss with you now. Okay, now problem statement. Always start your experiment with the problem statement. What are you trying to investigate? So you always have a question mark here. Now, what are the differences actually? Because why I change is a function of step up, because your hypothesis should be able to answer the problem statement. But I can see your hypothesis is just saying in a step-up transformer, the secondary voltage, we call it output voltage, is higher than the primary voltage. Okay, and a step-down transformer, the secondary voltage is lower than the primary voltage. So there's no function there. You're not talking about the function, isn't it? So I feel that the problem statement should be changed. So you put the differences. Okay, you are actually comparing the differences of the two types of transformer. So there's no function, right? The function is to convert it lah. Okay, so the hypothesis doesn't really match with the problem statement. So we change the problem statement. Okay, now variables, what are you doing here? You're going to test the variables. So you are going to change the number of turns. Okay, the secondary coil, you change the number of turns. You maintain the number of turns at the primary coil. So when you do the experiment, it's like this. You have the iron core here. Okay, iron core will be given to you. And then you wind the coil around one side. If this side is connected to the power supply, this will be considered your primary coil. So always remember primary coil, right? This one so happen to put 30 lah. Primary coil is always connected to your power supply. So this is your input lah, input voltage, whatever voltage lah. You can put here 2 volt, 4 volt, 6, 8, or 10 volts. Okay, this is called input voltage. Okay, and then you connect it to a bulb to show the brightness. So usually when the voltage is higher, you will see the bulb will light up brighter. If the voltage is low, then the bulb will be dim. Dim is opposite of bright. Okay, can just now I SMS look at your alternating current. Yes, you can also say both transformers use alternating current. Yeah, there's one of the similarity also can. Yes, it works on both types of transformer works on alternating current. Okay, now back to this one. So now you have your primary coil connected, always connect to the power supply. So this is the input voltage. Okay, now next one. Wait, where is it? Here. So what is the constant? Constant here is on the other side. So your secondary voltage, the primary is the one that you fix. The primary, you fix it at 30. Okay, and then the secondary is on the other side. So secondary here, secondary coil. So for the first experiment, you put to 15, half of it. Primary, you put 30 coils. You see the secondary coil, you see less, you see the color here, few less coils, isn't it? So here is or something to see, or you can even connect it to a galvanometer or something, or even an ammeter, right? To see the or you can see the voltage. You want to see brightness are easier to do lah. Okay, so you connect it to this bulb here. This is the load lah. Okay, this is the load. All right, so and then this will be the output lah. Output voltage. So output voltage will be shown by the brightness of the bulb. If the output voltage is high, all right, higher than your input voltage, this S bulb should be brighter than your P. If your input voltage is higher than the output voltage, then the P should be brighter than the S. Okay, so remember here, when we're talking about the voltage, right? When the voltage is high, that means your bulb will be bright lah. Okay, and then when the voltage is low, then your bulb will not be so bright. Okay, now, so let's look at this one. Now here is your, so 2 times you do the experiment. The first one is you have to put your primary coil at 30. all right? And then the secondary coil at 15. So now you're looking at primary coil is more, secondary coil is less, okay? And the next one, after you look at the brightness, all right? So here you will have to put your brightness. So here you put in either the word bright or dim. That's all. There's no value to measure. There is no ammeter, there's no galvanometer, no values. You just see which one bright, which one dim. All right, okay. Now after we go to Google Meet, we will discuss this because I can't see your response here. I want to answer you. Okay, next one. The turns, all right. If the second time, first time you do is primary coil is 30, secondary coil is 15. Then you look at the brightness. Second time now you change it. Your primary coil, you keep it the same. Now your secondary coil, you put 60. And then you compare the brightness and the dim. Which one bright, which one dim? Okay, I see a comment here. Let me check. Yeah, which one is dim, which one is bright? Now, P and S is dim. P and S is dim. For which one? For the first experiment or the second experiment? Okay, so this is, you have to compare which one is brighter. Okay, I give you a certain thing to remember. So if the more coils, all right, primary coil is more coil, secondary coil is less coil. That means the voltage at the input voltage is higher. The output voltage will be lower. Okay, if it's higher voltage will be bright. If lower voltage will be less, will be low, will be dim. Okay, so let's set you thinking first. Now, so this one, I will not give you the answer here. Right? The reason is because this is part of your experiment. We will discuss it afterwards in class. Okay, so for those who are following the lesson here, just to give you an idea that you have a higher number of coil here. Now the primary coil is higher. Your secondary coil is lower. All right, that means this one by right should be brighter. This one should be dimmer. So here for P is connected to where? P is connected to the input and your S is the output. So that means your P should be bright. Okay, so to give you an idea what you should get lah. So this, if you compare the brightness of the bulb, the P is actually, because here 30 30 means more, right? Then the secondary is on this side. This is less, so this one should be dim. This is how you should get it. Okay, now you change it the other way around. Now you maintain your primary coil. Primary coil, you don't change it, it's still 30. Now you only change your secondary coil. You increase it. Now your secondary coil looks like here is more. Your output voltage is 60 coil, means your output will be higher already. Okay, then your 30 comparatively is like a bit less. So now what is the brightness now? Maybe now here you get an idea what is the correct one. The first experiment. Okay, now this one, what about this one? The second experiment, 30 for the primary, but secondary is more coils. So this should be a step up or step down. The second experiment should be a step up or step down. Okay. From 30 is the primary coil is less, secondary coil is more. It's a step what? It is a step. Never mind. Okay, P is dim. Yes, P is dim, correct. P is dim because less 30 is less What about 60 then? 60 is your S there. So 60 should be your S is this is brighter. Okay, so you see the comparing there. All right, now you think it out first. After I will in the class, I will explain again. So for here, I will stop here first, right? Because I need to take attendance in your Google Meet. So the result of experiment, all this is actually, I will go through that in the next lesson when I talk about all this symbol, what's the NP, NS, and so on. Okay, so at the moment it's until here first, where you need to know that the brightness of the bulb depends on the voltage. If the voltage is high, your bulb will be bright. If the voltage is low, the bulb will be dim. That's how you get your answer. Okay, so you see the number of coil. Number of coil is more, that means the voltage should be high. The number of coil is less, the voltage should be low. So that's why when the number of coil is less, you get it dim. When the number of coils is more, you will get it brighter. Okay. All right. Okay. So yes, S is bright. Correct. Correct. Okay. So we will stop here first. Okay. So at the moment, you until here. The next lesson, I will go through the questions here with the calculation because you need to know the NP, NS, and so on. All right. Okay. So we will discuss that later in class. All right. So I will end the broadcast first. We go to the one. All right. Okay. Girls, bye bye. See you, Hannah.